Hello everyone, I'm James C. Baklan. Today I will discuss to you simple strain and stress strain diagram. So what is strain? Strain is the concept used to compare the elongation of material to its original and deformed length. Strain, represented by the symbol epsilon, is the quotient of elongation in the original length. Now strain has no units, but it's often given the unit of inches over inches or feet over feet. Now the formula of strain is epsilon is equals to delta L, or the change of length, over L sub O, or the original length. Now take note, in having the measurements, you should have the same units for all the given. Now this is just a representation or a comparison of what strain is. So when stress is applied to an object, it deforms. And just like Luffy, when you pull an object, it stretches. Or imagine a rubber band. Or for a person, um, imagine your friend is 20 kilograms 2 years ago. Then after 2 years, he becomes 40 kilograms. So there is a change of weight to your friend. Just like strain, for example, in a rubber band is 10 inches. The original length of a rubber band is 10 inches. Then when you pull it, it becomes let's say 12 inches. So there's a 2 inches added to the length of the rubber band. Now the ratio of the deformation of the two, when you solve that using the formula, it's called strain. Now there are two types of strain. The shear strain. Shearing forces cause shearing deformation. An element subject to shear does not change in length but undergoes a change in shape, just like the illustration below. Now the other type is normal strain. It is a term that describes the response of a solid to the application of a normal force, or a force that is perpendicular to the object's cross-sectional area. Now we have a sample problem here. Find the strain in a 75-foot cable experiencing an elongation of 1 inch. So take note that the units given are not the same. So we need to convert it uniformly. So the formula of strain is epsilon is equals to the change of length over the original length. Now it's stated that the change of length is 1 inch, and we need to convert that to feet. So 1 inch times 1 feet over 12 inches over the original length, which is 75 feet. We do the math, we have 1.11 times 10 raised to negative 3 feet over feet. Or it's a unitless, or it is unitless. Then for stress strain diagram. So a stress strain diagram or stress strain curve is used to illustrate the relationship between a material's stress and strain. A stress strain curve can be constructed from data obtained in any mechanical test where a load is applied to a material and continuous measurements of stress and strain are made continuously. So different materials have different stress strain diagram. So we have here an example of a stress strain diagram of a medium carbon structural steel. Here we can see in the x-axis is a strain, and for the y-axis is stress. So there are certain points in the when you graph the points of the stress strain of the certain material, we have a proportional limit, we have the elastic limit of a material, the yield point of a material, the rupture strength of a material. So that would be all. Thank you and God bless.